For centuries, two Jewish communities have shared the same ancient origin, yet their DNA tells two remarkably different stories. One journey led across Europe, the other stretched through Spain, North Africa, and the Middle East. Most people think that's where the story ends. It isn't even where it begins. When geneticists started decoding the DNA of Ashkenazi and Sephardic Jews, they uncovered something history had never fully explained: hidden migrations, forgotten ancestors, unexpected genetic markers, bloodlines that crossed continents and survived thousands of years of exile. What emerged wasn't just a family tree, it was a genetic record of survival, adaptation, and one of history's greatest diasporas. This isn't about religion. It isn't about politics or competing claims. It's about what happens when a single people are separated for centuries, shaped by different worlds, yet remain connected by an ancient origin written into their DNA. 5 major differences. 2 extraordinary communities, one shared beginning, and a genetic story that challenges everything most people think they know. Let's begin. And the answer is more layered than any textbook has ever admitted. Both Ashkenazi and Sephardic Jews trace their earliest roots to the ancient Levant, the land of Canaan, the kingdom of Judah, and the temple in Jerusalem. That shared origin is real, and it is confirmed by genetics. Both groups carry a measurable proportion of ancient, Near Eastern DNA markers that connect them to the same geographical homeland, going back 3,000 years or more. That part of the story is not in dispute, but then history intervened, twice, in 2 completely different directions. The Sephardic story begins with the Roman exile and the slow spread of Jewish communities westward across the Mediterranean. By the early medieval period, thriving Jewish populations had established themselves across the Iberian Peninsula in what is now Spain and Portugal. These communities, known as Sepharad in Hebrew, flourished under both Visigothic and later Moorish rule. They integrated into one of the most culturally sophisticated civilizations of the medieval world. They produced philosophers, poets, physicians, and astronomers. Maimonides was Sephardic. Judah Halevi was Sephardic. These were not isolated ghetto communities. They were participants in an intellectual golden age. Then came 1492, the Alhambra Decree. The Spanish Inquisition forced a choice: convert or leave. Hundreds of thousands of Sephardic Jews were expelled. They scattered across the Ottoman Empire, North Africa, the Balkans, and the Netherlands. And wherever they went, they carried their language, their customs, their Torah scrolls, and their DNA. The Ashkenazi story runs on a parallel but entirely separate track. Jewish migrants moving north through Italy and into the Rhine Valley between the 8th and 10th centuries formed the earliest Ashkenazi communities. These were small groups of merchants, traders, and settlers who established themselves in cities like Mainz, Worms, and Speyer. From there, waves of migration pushed eastward into Poland, Lithuania, and the vast territories of Eastern Europe, particularly after the devastation of Crusade massacres, which drove communities further from the Rhine. What happened next is where genetics gets genuinely strange, because unlike the Sephardim, who maintained relatively continuous contact with Mediterranean populations and absorbed significant North African and Moorish genetic influence, the Ashkenazim became extraordinarily isolated. Confined to shtetls, excluded from land ownership, and restricted to specific trades, they married almost exclusively within their own communities for centuries. The result was a population that genetically drifted away from their Middle Eastern origins at a remarkable speed. Modern DNA studies confirm this divergence with precision. Sephardic Jews show stronger continuity with ancient Levantine populations. Their paternal haplogroup profiles retain a higher proportion of Middle Eastern J lineages, the genetic signature most closely associated with ancient Semitic populations. Their maternal lines, while also carrying European influence, show detectable traces of North African and Iberian ancestry, reflecting centuries of life in the Western Mediterranean world. Ashkenazi profiles tell a different story entirely. Their paternal lines are dominated not by Middle Eastern markers, but by a complex mosaic of Eastern European, Caucasian, and even steppe-derived haplogroups. Their maternal lines are almost exclusively European, tracing back to a small number of founding women from northern Italy and Central Europe roughly 2,000 years ago, with the same ancient origin, radically different journeys, and the DNA remembers every step. There is a concept in population genetics called the founder effect. It sounds technical, but the idea is simple. When a large population is reduced to a very small group through disaster, migration, or isolation, the genetic diversity of everyone who comes after is determined almost entirely by that tiny founding pool. Rare traits become common. Unusual mutations spread. The genetic fingerprint of the survivors gets stamped onto every generation that follows. Both Ashkenazi and Sephardic Jews experienced versions of this, but the severity, the timing, and the consequences were dramatically different. And understanding those differences explains some of the most striking and most misunderstood facts about both communities. The Ashkenazi bottleneck is one of the most studied in all of human genetics. Current research suggests that the entire modern Ashkenazi population, estimated at roughly 10 million people worldwide, descends from a founding group of no more than a few hundred individuals. Some studies place that founding population as low as 350 people living in medieval Europe sometime around the 12th or 13th century. 350 people. From that impossibly small seed, an entire civilization grew. The consequences of that bottleneck are written into Ashkenazi DNA with unusual clarity. Certain genetic diseases appear in this population at rates far higher than in any other group on Earth. Tay-Sachs disease, which destroys nerve cells in the brain and spinal cord, occurs in Ashkenazi Jews at roughly 10 times the rate seen in the general population. Gaucher's disease, Bloom's syndrome, familial dysautonomia, and Canavan disease are all dramatically elevated. The BRCA1 and BRCA2 gene mutations, which significantly raise the risk of breast and ovarian cancer, appear in approximately 1 in 40 Ashkenazi women, compared to 1 in 500 in the broader population. These are not random misfortunes. They are the mathematical consequence of a small gene pool reproducing in isolation for centuries. When your entire population descends from a few hundred founders, whatever mutations those founders carried get passed down at far higher frequencies than they would in a larger, more diverse population. It is not a flaw in the people. It is a flaw in the mathematics of survival under extreme conditions. The Sephardic experience produced a different kind of bottleneck. Rather than a single severe narrowing, Sephardic populations went through multiple sequential compressions. The Iberian expulsion, the dispersal across the Ottoman world, and the establishment of isolated communities in cities like Thessaloniki, Istanbul, and Fez. Each relocation created a new mini-founder effect as smaller groups split off and settled in new territories. The result is that Sephardic genetic diversity, while broader than Ashkenazi in some respects, is highly structured geographically. Sephardic Jews from Morocco carry different genetic signatures than those from Turkey, who differ from those in the origin point. But here is where the bottleneck story becomes genuinely counterintuitive. The same genetic isolation that created elevated disease risk also created something unexpected. Ashkenazi DNA, precisely because of its unusual combination of Middle Eastern, European, and Eurasian components compressed into a small founding pool, produced extraordinary genomic heterogeneity in immune function. Studies have found that Ashkenazim carry a wider range of immune response variants than many larger populations. That diversity, paradoxically born from isolation, may have given them a survival edge during the plague epidemics that decimated medieval Europe. A bottleneck is not just a narrowing. Sometimes it is also a forge. This is the chapter that makes people uncomfortable because what the DNA found buried inside both Ashkenazi and Sephardic genomes does not fit the story that either community or their critics have wanted to tell. There are bloodlines in both populations that have no clear explanation, ancestral traces that point to places and peoples that Orthodox history never accounted for, and ignoring them does not make them disappear. Start with the Ashkenazim. When large-scale Y chromosome studies were conducted across tens of thousands of Ashkenazi men, researchers expected to find the J haplogroup dominating the ancient Semitic marker associated with Middle Eastern origin. What they found instead was that only 10 to 15% of Ashkenazi men actually carry that marker. The majority carry something else entirely. R1a, the haplogroup most associated with Slavic and Eastern European populations. Also present are G2, linked to the Caucasus Mountains, E1b, associated with North Africa, and Q, a marker found predominantly across the Asian steppe belt. Where did these lineages come from? One hypothesis has haunted Jewish historiography for over a century, the Khazar theory. The Khazar Khaganate was a powerful Turkic empire that dominated the steppes of Eastern Europe between the 7th and 10th centuries. According to multiple medieval sources, Arab chroniclers, Jewish correspondence, and Byzantine records, the Khazar ruling elite converted to Judaism sometime in the 8th or 9th century. When the Khaganate collapsed under pressure from the Rus and the Mongols, its population dispersed westward directly into the territories where Ashkenazi communities were simultaneously forming. The genetic signature of that migration may still be visible today. The R1a subgroup found in Ashkenazi men is not identical to the R1a found in modern Slavic populations. It carries a specific subclade marker, M582, that is almost absent among non-Jewish Eastern Europeans. This suggests it did not enter the Ashkenazi gene pool through intermarriage with Slavic neighbors. It arrived through a separate population, one that was already Jewish or became Jewish, before merging with the broader Ashkenazi community. Now turn to the Sephardim. Their mystery bloodlines run in a different direction, southward and westward rather than northward and eastward. Centuries of life in Moorish Iberia left a detectable genetic imprint. Studies of Sephardic paternal lines in particular have identified North African Berber haplogroups woven into communities whose oral history records no such ancestry. The golden age of Muslim Spain was not a period of strict separation. It was a period of cultural and, inevitably, genetic exchange. Jewish women converted into the community. Moorish neighbors intermarried across boundaries that religion drew, but daily life sometimes erased. Sephardic communities that resettled in North Africa after 1492 showed detectable Berber admixture across maternal lineages, a measurable and significant proportion in certain Moroccan Sephardic populations. Those communities spent centuries in the Maghreb before anyone recorded their history with precision. The DNA filled in the gaps. Two communities, two sets of ghost ancestors, both hidden in plain sight inside the genome. There is an argument that linguists and geneticists have been having quietly for decades. Does language shape a population's DNA, or does DNA shape its language? The answer, it turns out, is neither. What shapes both is isolation. And nowhere is that more visible than in the parallel linguistic universes that Ashkenazi and Sephardic Jews built for themselves across 5 centuries of separation. Start with the languages themselves. Yiddish emerged in the Rhine Valley communities of the 10th through 12th centuries. Its skeleton is Middle High German, the dialect spoken in the Rhineland during the period when the earliest Ashkenazi settlements were forming. But Yiddish is not German. It absorbed Hebrew vocabulary for religious and intellectual concepts. It borrowed Slavic grammatical constructions and vocabulary as communities pushed eastward into Poland and Lithuania. It developed its own literature, its own theater, its own press. By the 19th century, Yiddish was the daily language of millions of Jews across Eastern Europe, a complete civilization operating in a tongue that existed nowhere else on earth. Ladino followed a parallel path on the Sephardic side. Its foundation is medieval Castilian Spanish, the dialect of the Iberian Peninsula as it existed before 1492. When the Sephardim were expelled and scattered across the Ottoman world, they carried that medieval Spanish with them, and it froze in place. While the Spanish spoken in Spain continued to evolve, Ladino preserved 15th century vocabulary and syntax like linguistic amber. It too absorbed Hebrew terms, and depending on where communities settled, it incorporated Turkish, Greek, or Arabic elements. Sephardic Jews in Istanbul spoke a different flavor of Ladino than those in Thessaloniki or Amsterdam, but all of it traces back to the same Iberian root. Here is where language and genetics converge in a way that is rarely discussed. The isolation that produced Yiddish is the same isolation that produced the Ashkenazi genetic bottleneck. Communities closed enough to develop and maintain an entirely separate language for 5 centuries are communities closed enough to experience dramatic genetic drift. The linguistic boundary and the genetic boundary were enforced by the same social walls, the ghetto, the shtetl, and the legal restrictions that kept Ashkenazi Jews separate from their Christian neighbors, even as they lived among them for generations. The same logic applies to Sephardic communities. The preservation of Ladino across 5 centuries of diaspora in the Ottoman world reflects the same communal closure that kept Sephardic genetic profiles distinct from the Turkish, Greek, and Arab populations surrounding them. Language was not just communication, it was a fortress, a way of marking who was inside and who was outside without ever drawing a physical line. The ritual differences between the two communities reinforce this picture at every level. Ashkenazi prayer melodies carry the modal structures of Eastern European folk music. Sephardic liturgical music reflects the maqam scales of Ottoman and Arabic musical tradition. Ashkenazi Torah scrolls are dressed in fabric coverings and laid horizontally to be read. Sephardic Torahs are housed in rigid wooden or metal cases and read upright. Ashkenazi Jews name children only after the deceased. Sephardic Jews name children after living relatives. These are not trivial distinctions. Each one is a fossil record of a different environment, a different set of neighbors, and a different set of pressures shaping daily life over centuries. Culture is not separate from genetics. It is genetics made visible. Every tradition that survived is a tradition that was worth protecting fiercely enough to pass down, and both communities protected theirs with everything they had. For roughly 15 centuries, Ashkenazi and Sephardic Jews lived in almost complete separation. Different continents, different languages, different genetic trajectories, They shared a religion, a scripture, and a calendar, but almost nothing else about their daily existence overlapped. Then, the 20th century happened, and everything changed. The founding of the State of Israel in 1948 did something genetically unprecedented. It took two populations that had been diverging for 1,500 years and dropped them into the same small territory. Ashkenazi Jews arriving from Europe, Sephardic and Mizrahi Jews arriving from North Africa, Iraq, Yemen, Morocco, and Iran, Ethiopian Jews, Bukharan Jews, and Mountain Jews from the Caucasus. Within a single generation, communities that had never shared a neighborhood were sharing cities, schools, military units, and eventually families. The past 2 decades have begun mapping what happens when two highly distinct bottlenecked populations start intermarrying at scale. The results are striking. The children of Ashkenazi Sephardic unions show broader genetic diversity than either parent population alone. The founder effect mutations that plague both communities, elevated in isolation and concentrated by centuries of endogamy, are expected to dilute across generations of intermarriage, a pattern consistent with basic population genetics. The specific disease clusters characteristic of isolated Sephardic communities show the same expected pattern of dilution across generations of mixed ancestry. This is not assimilation erasing identity. This is two ancient rivers finally rejoining a common delta, but the reunion has not been frictionless. Inside Israel, the divide between Ashkenazi and Sephardic communities has carried real social and political weight since the earliest years of the state. Ashkenazi Jews, arriving earlier and in larger numbers, built the institutional architecture of the new country, its universities, its government ministries, its military officer corps, and its cultural establishment. Sephardic and Mizrahi Jews, arriving later and often from very different socio-economic backgrounds, frequently found themselves at the bottom of a hierarchy they had no hand in designing. The tension between these two communities, sometimes called the ethnic gap, the Freicha stereotype, and the Ashkenazi privilege debate, has shaped Israeli politics for 70 years and continues to shape it today. Genetics does not resolve that tension, but it reframes it, because what the DNA makes undeniably clear is that neither community holds a more authentic claim to Jewish origin than the other. The Ashkenazi profile, with its Slavic haplogroups and European maternal lines, is no more or less Jewish than the Sephardic profile, with its Berber admixture and Ottoman influences. Both are the product of the same ancient origin point filtered through radically different historical experiences. The argument about who is more authentically Jewish collapses the moment you look at the actual data. What the genome reveals instead is something more interesting than hierarchy. It reveals complementarity. The Ashkenazi gene pool brought one set of immune variants, cognitive, adaptations, and disease resistances shaped by centuries of life in Northern European conditions. The Sephardic gene pool brought a different set shaped by Mediterranean climates, Ottoman urban life, and North African environments. Together, the merged population carries a broader biological range than either group alone. Two populations, 15 centuries apart, reunited in one small strip of land on the eastern Mediterranean coast, and their children carrying fragments of both journeys inside every cell, are something genuinely new. The DNA does not lie, and what it says about this reunion is that separation was never the final chapter. Two communities, one ancient origin, 15 centuries of separation that left completely different fingerprints on the same genome. That is the real story the DNA tells, not a story of division, but a story of divergence. Two branches of the same tree that grew in opposite directions under completely different skies. What genetics has made undeniably clear is that Jewish identity in both its Ashkenazi and Sephardic expressions was never about purity. It was never about an unbroken line from a single ancestor to the present day. It was about survival, adaptation, the ability to absorb new environments, new neighbors, and new bloodlines, and still emerge on the other side recognizably, stubbornly, and defiantly Jewish. The Khazar markers in Ashkenazi DNA do not erase their Jewish identity. The Berber traces in Sephardic maternal lines do not dilute their connection to ancient Israel. They are proof that identity is not a blood test. It is a commitment, a tradition passed across a table, not through a chromosome. Most people look at their DNA percentages and stop there, missing the real story. If you enjoyed this documentary and want to uncover more forgotten histories, ancient mysteries, and the hidden stories buried in science and history, make sure to subscribe and turn on notifications so you never miss our next investigation. Thanks for watching, and we'll see you in the next documentary.